Welcome to Papa Junk Shop. Well, this is, I guess you'd say, take two, but the good part you didn't get to see. I got my MOSFETs. Of course, I ordered like 6 different things for this project, and of course these took the longest to get here. Not just for this, but for my whole changeover I'm going to do. And I had the camera set up showing me installing these in there, and I'm working away and I didn't realize it, and my camera decided to do a nod and it pointed down to show nothing. So we wiped that one out and you're going to see it all together. And I think maybe I figured out what caused the problem. Now when I took it apart, the insulators on the MOSFETs were just crushed right down to nothing. You could almost like see through them. They were just, you had to dig them off with your fingernail. And I'm thinking that maybe they pierced through that and shorted out. And when I used it on the water reel, you know, it worked, but we didn't have much current. And when I hooked it up to the solar panel to play with it while we're waiting for the water to come up, it worked for like 3 days and then quit. And I'm thinking that maybe it, you know, warmed up a little bit and those things made contact and shorted out. Don't really know for sure, just a theory, but I shouldn't have put that back in there. It's going to show you something. So what I decided to do is I worked on another inverter, and they had these nice little, just like a little pocket for the heat transfer stuff, and it just slides right over the whole thing like so. So that's what I put on all of them, and I found these on eBay, and I bought a package of 50 of them because they look like they'd be handy for other projects too. And if anybody's interested, not sure if that's gonna do you any good or not, but that's the label that's on it. Of course I had to wait for them from China, but they came before the MOSFETs. Okay, so I got it all back together, so now I'm going to try it. And when I put it back together, originally I had 30 amp fuses in it, so I put 20 amp fuses in it instead. That way I'll have a little more protection. And I've got a fuse block here, and I've got 10 amp fuses in it, so I'm going to use that to do my testing to make sure it's going to work. So I'm going to go ahead and get that hooked up, and I'll bring you guys back and show you if it works. Okay, so I've got minus going to here, and this is the minus that's going to go to the battery, and the plus goes to here, and this is the plus to the battery. The minus is the green one, goes to here, plus is the brown one on the white end, goes to there. So let's hook the battery up. See what we get. Hopefully we're going to get a screen lit and not fuses lighting. Hey! Alrighty. Hopefully you guys can see it. Screen lit up. Okay. Says the battery's at 12.4 volts. Okay, I got a bench power supply. and that's what I'm going to power this up with. Okay, let's see, the minus is here, and the plus is here. Okay, so fire up the bench supply. Okay, I got 1.7 volts. We'll see when it wakes up. I'm going to slowly turn this up. Okay, I got the picture of the solar panel. That's at about 8.1 volts. 9, 10, okay, we're starting to show some current. Hey, the current's working. Alright, so maybe it fixed that part of it too. Okay. So I got like 18 volts coming in on my power supply. Of course these wires are real light, so it's probably okay. There, I'm about 20 volts on the power supply. And I got 1.2 amps on the solar panel, 1.6 amps going into the battery. Okay, all the battery's up. I got a little light bulb here, let's throw that on there. Okay, that changed things. Okay, now we got 2.7 amps coming in from the solar panel, well, power supply, 3.5 going into the battery. And I got it set for 14.8, and that's what it's at. So let's turn this down and put a cloud up there. Run the battery down a little bit. So we got 0 amps, 8.5 volts on the power supply. Oops. Okay, I'm going to turn this back up. Okay, about 20 volts. And it didn't wake back up. There it goes. Well, so why didn't it wake back up? You guys probably can't see that too well, so I'll take you off the tripod here and we'll get a closer look. Okay, here's maybe a little better look at what I got. There's the fuse block going into that. That's a real mess of little light wires, just for testing. So I left that bulb on there for a while so it could run that battery down. We're down to 11.9, so turn the power supply back on. Let's see. And I'm turning it up. Okay. about 20 volts coming in. Light went out. Okay, 3.9 amps from the solar panel and 5.1. So before, this amperage part quit before the whole thing quit. So now that's working again. So there was something wrong right from the get-go. Yeah. Once it got some real current going through it, apparently the rest of it went too. So over here, we're seeing this one on the unit itself. 20 volts coming in. 3.1 amps. .8, so it's got the battery charged up again. 3.8 amps. It's probably that light bulb draw. So I think we're golden. All right, back in business. Yeah, give you a little peek of what I got in mind for my. I don't know if you call it an upgrade or not. In some respects it is. I'll have better control of things. Before I used to use it all up as I got it with the grid tie thingy, but them are gone, so now I gotta have control of things, so I gotta have all this electronic stuff, which is trouble, but oh well, that's part of the game, I guess. So what I've done is I've made a couple of bus bars, and they were 3/8 copper. They were a bus bar originally, but they only had a screw every 6 inches, so I added a few more screws, and I made some little plexiglass insulators, set them off, and I got a lug bolted and soldered on the end, each one of them, so that's going to be part of it. And the water wheel and the windmill, of course, I need to be able to shut them down when the battery gets up and go into a dump load. So I got a little voltage detection board, and I've already played with it a little bit, and it seems to work alright. You put power in here, the voltage you want to detect goes here, and there's a relay here with normally open, normally closed contacts. So I'll use this to run another relay, which is, a lot of them use a thing like a car solenoid. Well, I want to switch both sides, so I found this relay in my collection. Matter of fact, I had 2 of them, and it's pretty heavy duty, 24 volt coil, but it does work on 12 volts. And to make sure, I changed these springs to just a little bit lighter, so it pulls down for absolute sure. And there's four sets of contacts, so I'm going to tie 2 together for the minus and 2 together for the plus. And this board will run this coil to run this, and of course I'm going to use one of these fuse blocks in there, and we'll use an ammeter. And what else? I guess we get that all mounted up. Oh, yeah. That's over here on the bench. My, or on a different bench. That's going to be my dump load. So I'll be putting that together, and I'll probably show you as I go along in another video. So we'll get that assembled and give it a test. So I guess that's about it for now. So if you enjoyed it, give me a thumbs up, and if you haven't subscribed, please do, and thanks for watching. We'll see you next time. Yeah, there was one more item that I didn't show you that I got. These are a little thermal switch. I guess it's not going to focus on it. Anyways, I'm going to use these on the heat sinks, and when it gets up to around 100 degrees, if I remember right, it'll come on, turn a fan on. So I'm going to integrate that into the PWM and probably the MPPT control, just to make sure that they don't overheat. Alright, now I'm going.